Bismillahirrahmanirrahim. Assalamu alaikum, dear students. I hope you are doing well. Dear students, this lecture is for grade 10, subject chemistry, chapter number 16, chemical industries. This is my 33rd lecture, and I am your lecturer, Mrs. Saira Jamal. Dear students, in this lecture, I'm going to talk about the metallurgical operation and the steps we were discussing last time. It was about the extraction of metal from its ore, and the step which we were discussing, it was smelting of copper. What is smelting? The method to reduce metal ions to free metal is called smelting. But for smelting, we use most common reducing agents such as coke, carbon monoxide, and hydrogen. Mostly we use these compounds or these substances as a reducing agents. Smelting of copper ore is done in two steps because in the first step it was converted into the sulfides of copper and iron, copper sulfide and iron sulfide, which are combinedly called matte. So the roasted copper, in which the copper is converted into copper sulfide and iron sulfide, that roasted copper ore is heated with coke and sand at about 1100 degrees centigrade. The materials melt and separate into two layers. The bottom layer that contains mixture of copper sulfide and iron sulfide is called matte, while the upper layer is a silicate slag formed by the reaction of iron oxide and sand. By the this roasting, again roasting of that matte, what will happen? Some of the iron sulfide will oxidize into iron oxide. That iron oxide will then react with the sand and will form slag or iron silicate or slag. You can see iron silicate or slag is lighter than the molten metal, so it will make an upper layer and we can easily drain it out or remove it out as an upper layer, while the lower layer is of the molten metal, that is of the copper sulfide and iron sulfide, which is called matte, and most of the iron is removed as a slag in the form of iron silicate or as a slag. This you can see is the furnace which is used for this purpose, and ore, coke and limestone are added from the upper side of this furnace, and then hot air is passed through this furnace. And what will happen when hot air is passed through this furnace? That hot air will react with the ore and coke and limestone, and will form iron silicate as a slag, and molten copper like matte will collect it at the bottom of this furnace. As I told you that the iron sulfide react with oxygen in roasting process and will convert it into iron oxide. This iron oxide then react with the silicate, which is also called sand or silicate, silica, and will form iron silicate. This iron silicate is called slag, and this slag is lighter than the molten metal. After this step, the next step is basimerization. In a basimerization process, air is blown through the molten copper matte. Matte, I told you, is iron sulfide, mixture of iron sulfide, molten iron sulfide, and copper sulfide in a special apparatus called Bessemer converter, and any remaining iron sulfide. Most of the iron sulfide oxidized into iron oxide, but still some of the iron sulfide left. So that iron sulfide is oxidized and removed as a slag, and that slag is iron silicate. In the final smelting step, cuprous sulfide is oxidized to form oxide. Now sulfides are oxidized into the oxide form, copper oxide form, which react with the remaining cuprous sulfide to form metallic copper. After removing the iron oxide, you can see this is the Bessemer converter. Hot air is passed through this Bessemer converter. There are holes in this Bessemer converter. Through these holes, The hot air enter into the decimal converter. In decimal converter, the ore, like the you can say the matte, react with the which contain iron sulfide and copper sulfide. So the copper sulfide then react with the copper oxide, and after reacting with copper oxide, we can say that we will get the metallic copper. This is, you can see, copper sulfide in this decimal converter react with the oxygen of the air, and this copper will then oxidize and will give copper oxide along with sulfur dioxide gases. So this copper sulfide which is formed, and the remaining the copper oxide which is formed, and the remaining copper sulfide, because all of the copper sulfides are not oxidized into copper oxide. Suppose if 80% of the copper sulfide is oxidized into copper sulfide is oxidized into copper oxide, still 20% copper sulfide is left. So that copper sulfide then react with the product copper oxide and will give us metallic copper and sulfur dioxide. This metallic copper which is formed is called blister copper, and it is about 97 to 99% pure copper, and it entraps some air bubbles in it, and those air bubbles of sulfur dioxide. So basic mineralization, and that's why it looks like blisters. That copper looks like blisters because sulfur dioxide is entrapped. Bubbles of sulfur dioxide entrapped in the copper metal. Decimerization is also used to convert bare iron into steel. Decimerization is not only used for copper, but also it can be used for the conversion of iron into steel, which is an alloy of iron. Then the next step is refining of metal. After extraction of metal, the next step is the refining of metal. The metal obtained as a result of smelting, first of all roasting, then after roasting, smelting, then after smelting, the next step is refining of metal. So the metal obtained as a result of smelting contains some impurities. It must be refined, and for to refine it, forming methods may be used. So the first one is electro refining. Electro refining, you learn it in the grade 9. It is called electrolytic refining, and electrolytic cell is used in electrolytic refining, in which the pure metal acts as an anode, and and a sample of pure metal act as a the impure metal act as an anode, and a sample of pure metal act as a cathode. For example, electrolytic refining of copper is carried out in an electrolytic tank containing acidified copper sulfate as an electrolyte. Electrolyte, I told you, is a solution which completely ionizes in water and gives ions. So copper sulfate will give copper ion and sulfate ion, and it will act as an electrolyte because for the completion of the electrolytic circuit, an electrolyte is compulsory. Three ions are compulsory. Impure slab of copper act as an anode, and pure copper act as a cathode. On passing electric current through the solution, impure copper dissolves, forming copper ion, gain electrons at cathode, and then form metallic copper. That copper will then deposit it at the cathode. In this way, pure copper is collected at cathode. The impurities like gold, silver fall of the anode as anode mud. It will be collected in the solution. So anode reaction, at anode always oxidation takes place. So copper will get oxidized at anode and will give 2 electrons, and at cathode reduction takes place. So the copper ion which produced at anode will go into the solution and then will move towards the cathode. When they reach cathode, they will gain electron from the cathode and then convert it into the metallic copper. That metallic copper will then deposit it at the cathode. So this is the electrolytic refining of copper. Electrolytic refining of copper. Electrolysis allows the dissolution of copper from the impure blister copper anode and deposition of pure copper on the copper cathode. You can see in this electrolytic cell, there are many anodes and cathodes. So you can see that the pure copper cathode size will go on increasing, and that of the impure copper will go on decreasing. You can see the size of anode decreases while that of the cathode increases and all the impurities will settle down as the slime or as an anode mud, anode slime or as a anode mud in the bottom. And these are the anodes and cathode. And this is called electrolytic refining of copper. Then one more method for the refining is distillation. Metals with relatively low melting points such as arsenic and mercury are refined by distillation. Distillation, you know, it is a very simple process and based on difference in the boiling point of the impurities and the metal. So on the basis of the differences, the metal will left behind and the impurities which have the one which has low boiling point will convert it into the vapor form and then we can receive it or condense back it into the receiver flask. So depending upon the melting point or depending upon the boiling point of the metal and the impurities. Volatile metals form the vapor first and separated by condensing in air. So definitely that metal which is volatile or which can easily converted at low temperature into the liquid state into the gaseous state that we converted into the gaseous state and then after condensation we collect it into the receiver flask. But those substances which have high temperature or high boiling point, they will left behind in this volumetric or in this round bottom flask. So this is all about the metallurgical operations or extraction of metals from its ore. Now coming towards the next topic, the next topic is about the Solvay's process. What is Solvay process? Sodium carbonate, Na2CO3 is the formula of sodium carbonate. It is also called soda ash and it is an important industrial chemical. It is used in the manufacturing of glass, soap, detergents, paper, and many other important chemicals. So this sodium carbonate or soda ash, or it is also called washing soda. It is used by a process called Solvay's process. And Solvay is the name after the scientist or the engineer who for the first time he like construct this plant for the production or for the preparation of soda ash, sodium carbonate or washing soda. Sodium carbonate is manufactured in a continuous process known as the Solvay's process. What are the raw materials required for this process? The raw material required are ammonia gas, brine, concentrated solution of sodium chloride is called brine, then limestone as a source of carbon dioxide and slackline, calcium carbonate, CaCO3 is called limestone. So that limestone is used because limestone after reaction with water and after heating and then reaction with water will give us carbon dioxide gas and slackline, that is calcium hydroxide. So for the calcium hydroxide and carbon dioxide, we use one raw material that is limestone. It is also called calcium carbonate. Then what are the basic reactions of Solvay process? Solvay process consists of the following steps. The first step is preparation of ammonical brine. Ammonical brine is prepared by dissolving ammonia gas in brine. Brine, I told you, is the concentrated solution of sodium chloride. Ammonical brine is fed into the carbonating tower. When ammonia and brine is mixed together, then they are passed through carbonating tower. What happens in carbonating tower? In carbonating tower, carbonation takes place. What is carbonation? Carbonation means reaction, carbon dioxide gas is passed through this ammonical brine. So this carbon dioxide first react with ammonia and water and will give ammonium hydrogen carbonate. This ammonium hydrogen carbonate then react with the brine or concentrated solution of sodium chloride and will give sodium hydrogen carbonate and ammonium chloride. Sodium hydrogen carbonate is also called sodium bicarbonate and it is also called the baking soda. Baking soda is called sodium hydrogen carbonate or sodium bicarbonate along with side product ammonium chloride. In the lower compartment of carbonating tower, the temperature of the mixture is lower to 15 degrees centigrade and at this low temperature what will happen is Sodium hydrogen carbonate precipitates out or solidified out. Sodium hydrogen carbonate or baking soda or sodium bicarbonate, same. Then, when the sodium bicarbonate is formed and it precipitate out, so the ammonium chloride is in the solution form, like it is soluble in water, while sodium hydrogen carbonates are in the solid precipitate form, so we can separate out both by filtration. After filtration, sodium hydrogen carbonate will left out on the filter paper, and the like ammonium chloride will go into the solution. This sodium hydrogen carbonate I told you is used as a baking soda. Then next step is calcination. This sodium hydrogen carbonate which is formed, it is heated to get sodium carbonate, which is our required product. That is soda ash, sodium carbonate, or it is also called washing soda. Then this sodium hydrogen carbonate, as I told you, after heating is converted into soda ash, carbon dioxide gas will form and water vapor will also form. So carbon dioxide which is formed in this step, which is released, is recycled in the process, because if you remember in the first step, that is in the carbonation or in the carbonating tower, carbon dioxide is used. The carbon dioxide which is produced in this step, it is recycled and it is utilized in that step. Preparation of carbon dioxide and slag lime, as I told you that the calcium carbonate, which is also called limestone, it is used after heating, it decomposed into calcium oxide and carbon dioxide. This calcium oxide and carbon dioxide will form. So carbon dioxide is fed into the carbonating tower. You can see carbon dioxide is reproduced in this step. It is also reproduced in this step. So it means that carbon dioxide is, we can recycle it and reuse it, use it and then reuse it again. So carbon dioxide is spread into the carbonating tower from the top. Equal amount of lime, that is calcium oxide, and water are mixed to produce slag lime, calcium hydroxide. And slag lime is actually required for the ammonia recovery. As carbon dioxide is recovered, so ammonia can also be recovered by the reaction of slag lime and ammonium chloride, which is formed in the step where sodium hydrogen carbonate was formed and ammonium chloride was formed. So that ammonium chloride will react with the calcium hydroxide, which is formed from the slag lime, and which is formed from the limestone, and which give calcium oxide, and this calcium oxide then after reaction with water will give us calcium hydroxide, which is called slag lime. So slag lime react with the ammonium chloride, which is formed along with this sodium hydrogen carbonate, and then they will produce ammonia. This ammonia is recovered and it will be utilized in the first step. Calcium chloride and water are formed as a side product. Almost all ammonia is recovered in this process. The ammonia which is used in the first step is recovered in this ammonia recovery step. This is a Solvay process plant. You can see brine is added to the ammonia gas, ammonia absorber. Then a brine and ammonia absorber will react together. After reaction, then reaction and filtration, they pass through the carbonating tower. In carbonating tower, you can see carbon dioxide gas is passed through the carbonating tower. In this carbonating tower, carbon dioxide react with this ammonia and brine solution and will form this ammonical brine. After passing through the carbonating tower, carbon dioxide gas is passed through it. After passing the carbon dioxide gas through this carbonating tower, I told you that what will happen, the product like sodium hydrogen carbonate and ammonium chloride will form. Also, ammonium chloride and a little of ammonium hydrogen carbonate will form. That sodium hydrogen carbonate I told you is in this carbonating tower due to low temperature. This ammonium hydrogen carbonate precipitates out, and to remove it from this ammonium chloride solution and a little of ammonium hydrogen carbonate, it is filtered. After filtration, we will get the precipitate of sodium hydrogen carbonate, and this sodium hydrogen carbonate we can use it as a baking soda. And after heating the sodium hydrogen carbonate, we can get the sodium carbonate, which is our required product. But this ammonium chloride, which is formed as a side product, this ammonium chloride is passed through the ammonia recovery tower, and also the slack line, which is formed calcium hydroxide, which is formed, is passed through this ammonia recovery tower, and steam is passed through it, and it will form ammonia, and that ammonia and small amount of carbon dioxide is reutilized in the first step. Carbon dioxide is utilized in the carbonating tower, and ammonia is utilized in the first ammonia absorber step. So you can see that a limestone, it is this limestone after heating is decomposed into carbon dioxide and calcium oxide. Carbon dioxide is reutilized in the carbonating tower, and the calcium oxide react with water and will form um, slack lime, and this slack lime I told you is passed through the ammonia recovery tower, where it reacts with the ammonium chloride and will give us ammonia and carbon dioxide, and that ammonia and carbon dioxide is reutilized. So this is all about the Solvay process plant. Coming towards the flow sheet, how to draw the flow sheet of this Solvay process. You can see that represent each reactant. The box represent, or this rectangle represent reactant and product. Each reaction chamber or container with one box, we will mention the reactant and product separately in one box. In separate boxes, we will represent them. You can see brine react with ammonia. They are two different reactant, so we will mention them in separate boxes. One reactant is brine, one reactant is ammonia gas. It will pass through the carbonating. This will give us ammonical brine, that is the product. This product is then passed through the carbonating tower or carbonation tower. This is the step. Next step is in the carbonation tower. This shows the formation of carbon dioxide with a box. This box CO2 show production of carbon dioxide, which is connect it with the carbonating tower. So carbon dioxide connecting with the carbonating tower means that carbon dioxide is passed through the carbonating tower. And these are the calcium carbonate, which shows that after heating it will give two products, carbon dioxide and calcium oxide. Calcium oxide is used to produce slack lime, and carbon dioxide is passed through the carbonating tower. Next step is show formation of two products from the carbonation tower. As I told you, from the carbonation tower, this tower, two products are formed. When carbon dioxide gas is passed through ammonical brine, it will give ammonium chloride and sodium bicarbonate, which is also called baking soda. Then show formation of two products from the carbonation tower. This flow sheet show the formation of two products from the carbonation tower. Then we have the next step is sodium hydrogen carbonate, which is also called baking soda. After heating, it will give sodium carbonate and carbon dioxide. This carbon dioxide is utilized in carbonation tower, and this sodium carbonate is our product. Now this is next one is the recovery of ammonia or the recovery of the reactant. First one is the recovery of ammonia. To recover ammonia, the calcium hydroxide that is formed from the calcium oxide when it reacts with water. This calcium oxide then react with the ammonium chloride and will give the ammonium chloride and will give ammonia, or will recover ammonia. That ammonia which is produced, you can see here, ammonia recovery tower. It is passed to ammonia recovery tower. In ammonia recovery tower, it will give us ammonia and calcium chloride. This ammonia is then utilized in the ammonia tower, the first tower. So the overall flow sheet diagram of Solvay processes, you can see the first one is concentrated solution of sodium chloride, and ammonia gas is passed over there. They will give us ammonia brine. This ammonia brine is then passed to a carbonating tower. For carbonation tower, in carbonation tower, carbon dioxide is passed through this ammonical brine, and then after passing carbon dioxide through it, after carbonation, it will give two products, ammonium chloride and sodium hydrogen carbonate. This is also called sodium bicarbonate. This ammonia chloride is utilized in ammonia recovery, while sodium hydrogen carbonate, I told you, which is formed, it precipitates out at low temperature. Then after filtration, we can separate out the ammonium chloride and sodium bicarbonate. The sodium bicarbonate after heating will give us sodium carbonate and carbon dioxide gas. Sodium carbonate is called soda ash, which is our required product, while carbon dioxide is reutilized in the carbonating tower. Now, from where this carbon dioxide gas comes? This carbon dioxide gas comes from the calcium carbonate, which is called the limestone. By heating limestone will give us two products, carbon dioxide gas and calcium oxide. Carbon dioxide gas is utilized in carbonation tower, while the calcium oxide it react with water and after reaction will give slag lamp. The slag lamp and ammonium chloride will react together to form ammonia and calcium chloride. Ammonia is reutilized in the first step, that is by the in reaction with brine. This was the overall flow sheet diagram of Solvay process. What is the advantages of Solvay process? It is a cheap process. The raw materials are cheap and easily available. It is a pollution free process. No harmful products are produced. It consumes less fuel. This is because there is no solution to be evaporated because evaporation utilize more fuel. Evaporate to remove water, more fuel is or more heating is required, which utilize more fuel. So as there is no evaporation, so less fuel is consumed. Carbon dioxide and ammonia are recovered and are reused in this process, and it produces a pure sodium hydrogen carbonate, which is called baking soda, and sodium carbonate, which is called soda ash or washing soda, is produced by this process. So this is all about the Solvay process. Dear students, hope you understand this lecture. The next topics, inshallah, we will learn in next lecture. Till then, take care. Allah.